So today we are going to talk about ellipses. Here is a definition of an ellipse. An ellipse is the set of points, I'll call them x comma y, satisfying an equation of the form x minus h quantity squared over a squared plus y minus k quantity squared over over b squared, excuse me, is equal to 1. So this thing here is called the equation of the ellipse. Any equation which has this form, if you graph it, will look like an ellipse. And just to make it clear, an ellipse is basically an oval, right? It's something that looks like this. That's an ellipse. In any actual ellipse equation that you have, the only variables will be x and y. H, k, a, and b, those will all be specific numbers. Now what I want to tell you is what do each of these numbers, h, k, a, and b, do to the ellipse. Obviously, as you modify them, you somehow change the shape and position of the ellipse, and I just want to explain exactly how that works. So for one thing, we have what is called the center of the ellipse. It's right there. There's the center. The coordinates of the center are given by hk, which, if you remember, is exactly the same as it was for circles. So that h and that k determine the coordinates of the center of the ellipse. Then we have these 4 points, which are kind of like corner points. They are called vertices. So vertices is the plural of the word. The singular version of that word is vertex. So this is a vertex, and that's a vertex, and that's a vertex, and that's a vertex. So they're like 4 corners of the ellipse. What do A and B tell you? A tells you the distance between the center and one of the left-right vertices. So this distance right here is A. So if you want to know what's the distance between the center and one of these left-right vertices, the answer is A. Okay? Not surprisingly, B is the distance between the center and one of the up-down vertices. So this is B right here. This is also B right here. So that tells you what H, K, A, and B do in this equation. Just a couple of extra things to say about this. One thing is the following: if A is bigger than B, then the ellipse is what I call a horizontal ellipse, or I suppose, if you like, a left-right ellipse. It looks like this. Okay, so it's kind of, horizontally oriented. On the other hand, if A is smaller than B, then the ellipse is vertical, and it looks something like that, which is not surprising because A basically determines the width of the ellipse, more or less, and B determines the height of the ellipse, more or less. So if A, which is the width, is bigger than B, which is sort of the height, then of course you've got an ellipse which is wider than it is taller. A couple more definitions. We have something called the minor and major axis. So if you have a horizontal ellipse, then this length right here, this segment from the left vertex to the right vertex, that is called the major axis, and this segment right here from the top vertex to the bottom, that is called the minor axis. Major in this case because it's longer than the minor. On the other hand, if your ellipse is vertical, then this segment is longer, and therefore that is called the major axis, and this segment here is shorter, and that would be called the minor axis. So that's just some vocabulary. There is one more thing I need to tell you about ellipses, and that's the following. So we define C as either, I'm going to give you two formulas. C is equal to square root of a squared minus b squared, or C is equal to square root of b squared minus a squared. Now I'm giving you two different formulas for this number C. I'll tell you what C represents in a moment, but first I want to address the fact that we have two different formulas for C. Which one do you use? The answer is you use whichever one produces a positive number underneath the square root. We don't want a negative number underneath the square root. That would be like a complex number or something. So you use whichever formula produces a positive number under the square root. Okay? So if a squared is larger than b squared, you would use this one. If b squared is larger than a squared, you would use this one. All right, so this number C that I've just defined, what does it correspond to geometrically? What does it tell you about the ellipse? In addition to all of the little things that I defined earlier, the center and the vertices, and I talked about, the major and the minor axis, there is one additional sort of piece to an ellipse, which are called the foci. Okay, foci, and that is plural. The singular is focus, a bit strange. It's like radius and radii. So what are the foci? In this picture right here, the foci would be, well, there are always two of them. In this picture, one of the foci would be maybe about here, and the other focus would be perhaps here. So I use stars to represent the foci. They're not technically part of the ellipse. What I want to say is that there is sort of a geometric meaning to the foci, which I'll explain in just a second. Actually, I guess I'll explain it now. So here's the meaning of the foci. It's a bit strange, but bear with me. Suppose you have a piece of string, okay? So you have some piece of string, maybe like this long or something, and you nail each end of the string here and here at the location of the foci. And then you pull the string taut. Okay, so here's my string. It's nailed at the ends to the two foci, and I pull it taut in this direction, and it's right here. Now, if I keep the string taut, okay, focus on this point right here. If I keep the string taut, I'm still pulling it tightly, but then I move the string. The idea is the string will trace out the ellipse. Okay, so you can see some different positions of the string here. Here the string is being pulled in this direction. Here the string is being pulled in this direction right here. Here the string is being pulled in that direction here. So the foci are these funny little points where if you nail a string to them, and you have a string of the right length, and you pull the string taut, and you kind of like trace out with your finger, you will obtain the ellipse. Now this kind of gives you a geometric definition of the ellipse. To my mind, it's not that important, but you should know something about it. The only other thing to say about this is, so I told you that C, this number we defined here, had something to do with the foci. So what does it have to do with the foci? C is the distance from the center to the foci. Okay, so this distance right here is C, and this distance right here is C. Don't make the mistake of thinking that the focus is halfway in between the center and that vertex. It's not. Okay, it's determined by this number C. Now, what I want you to notice is that I drew a horizontal ellipse here, and the foci were to the left and the right of the center. If you have a vertical ellipse, right, then the foci are not to the left and the right of the center, but actually above and below. But once again, the distance from the center to the focus is given by this number C right here. Okay? If you're a little confused about the geometric definition I gave of the foci, like involving that string, don't worry about it. It's not going to matter in this lesson. I'll give you a more striking demonstration of it in class with an actual piece of string, and you'll see what I mean. Okay, so there are a handful of problem types that we should be familiar with. One thing that we should be able to do certainly is we should be able to graph ellipses, okay? So from their equations, that is. So let's talk about graphing ellipses. So if someone gives you the equation of an ellipse, you should be able to graph it. So let's consider something like, let's graph x minus 1 quantity squared over 4 plus y plus 3 quantity squared over 9 equals 1. You should, first of all, recognize that this equation structurally looks like the equation of an ellipse, right? It matches it. Here's the general form of an ellipse, right? Down here, you can see how they match up. And, you know, the first thing you should sort of do is just recognize what is H, what is K, what is A, and what is B. Once you've done all those things, it's pretty easy to graph the ellipse. So let's have a look. H is certainly 1. K is... Remember, these things are like the opposite of what they look like. The equation is y minus k. So what are we subtracting here? The answer is -3. Remember, this number down here is a squared. So a is not 4, but rather 2. And this number down here is b squared. So b is not 3, but b is not 9, but rather just 3, right? Because that is b squared right here. Okay, so what does this information tell us? Well, first of all, it tells us the center. Remember, the center is always located at h comma k. So these are the coordinates of the center. So, you know, if I've got a grid, then I should go 1 over and 3 down, and that right there is my center. Now what I can do is I can use A and B to determine the location of the vertices, right? There are going to be 4 of those. A gives you the distance from the center to the left-right vertices. So since A is 2, if I move 2 units, so let me get some extra grid marks on here. If I move 2 units to the left, that will be a vertex. And if I move 2 units to the right from the center, that will be a vertex. Okay? And then B gives me the distance between the center and the up-down vertices. So if I start at the center and go up 1, 2, 3 units, that will be a vertex. And if I start at the center and go down 1, 2, 3 units, that will be a vertex. Well, now that you have the 4 vertices, remember these are like the 4 corners of the ellipse, it's pretty easy to graph it. You just go, and there it is, you know, and that's good enough. I do, however, want to also find the coordinates of the foci. They're not necessary to graph the ellipse, but it is something we should be able to do. So let's find the foci. If you remember, the foci are associated with this number c here, right? It's either root a squared minus b squared or root b squared minus a squared. Looking here, remember, we want to use the formula which produces a positive number under the square root. So is this going to be 9 minus 4, that would be b squared minus a squared, or is it going to be 4 minus 9, that would be a squared minus b squared? The answer is it's going to be 9 minus 4 because that will produce a positive number underneath the square root. We don't want complex numbers here. So that's the value of c. Now, what does c tell you? C is the distance between the center and the foci. But if you remember what I mentioned previously, there are only two foci. And if your ellipse is horizontally oriented, then your foci will be to the left and the right of the center. But if your ellipse is vertically oriented, then your foci will be above and below the center. Our ellipse is vertically oriented. My drawing's not perfect, but you can see that B is larger than A, which means that drawn to scale, this thing should be taller than it is wider. So it's a vertically oriented ellipse, which means that the foci are going to be above and below the center. How far above and below? Square root of 5. So what I need to do is start at the center and go up by root 5 units. One focus will be there. Start at the center and go down by root 5. The other focus will be there. Of course, you're wondering, how do you go up and down by square root of 5? That's an irrational number. The answer is you just use your calculator to get a decimal approximation of root 5. I don't know exactly what the decimal approximation of root 5 is, but it's a little bit bigger than 2. So if I start at the center and go up by 2 and just a little bit more, there will be a focus there. And if I start at the center and go down by a little bit more than 2, there will be a focus there. We can, if we like, write down the coordinates of the foci. Of course, the foci have the same x-coordinate as the center, which we said was 1. Now, what is the y-coordinate of this focus? Well, it's the y-coordinate of the center plus that distance right there, which is root 5. So the y-coordinate of the center was, of course, negative 3. And then to go up here, I add root 5. So that's the coordinate of one focus. This focus here is going to be 1 comma negative 3 minus root 5. So those are the coordinates of the foci. Okay, so that's graphing ellipses. Pretty straightforward. There's one other kind of problem type that I want to discuss, and then we'll be done. And that's the following. So there's a kind of problem where we give you some, I guess, random information about an ellipse. Maybe I tell you the center, maybe I tell you the locations of the foci or the vertices or something, and your objective is to find the equation of the ellipse, okay, given this information. So let's just do one of these. These can be a little bit tricky, but I'll show you how to do them. So suppose you have an ellipse. So an ellipse has foci at, let's say, 3, 2 and 5, 2, and a vertex at, let's say, 1, 2. Okay? So that's the random information that we've been given, and the instructions are find the equation of the ellipse. Okay? Now, one thing that you have to recognize is that because this is an ellipse, we already know the form of the equation. It has to have the form x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. All we have to do is fill in the unknowns. We have to determine h, k, a, and b. Remember that x and y are meant to be variables in the equation. Those won't be replaced with anything in our final answer. But h, k, a, and b must be replaced with something. Those must be found. All right, so how do we do that? What you need to do in all of these problems is take the information that you've been given and draw a picture. It doesn't have to be to scale, but you have to somehow represent this information visually. Otherwise, it's very hard to do. So let's see what we're told. We're told that we have foci at 3, 2 and 5, 2. Now I just want you to ask yourself, 3, 2, if you're thinking about a grid, 3, 2 and 5, 2, are those foci going to be oriented like this, left and right, or are they going to be oriented like this, up and down? Well, because the y coordinates are the same, they're going to be oriented horizontally. Okay, so 3, 2 and 5, 2 are maybe like here and here. Okay, so 3, 2, and 5, 2. Notice that I'm not really drawing any hash marks. I'm not making this to scale. That's not important. It's just the general orientation that you have to get right. And of course, I'm using stars to represent foci. I use dots to represent vertices. And then we have a vertex at 1, 2. So where would that be? That's the same height as these two guys here. It's just going to be a bit more to the left. So I've got a vertex right here. Maybe I'll just label that with a V to signify that it's a vertex. All right, now what can I determine from this? Well, of course, I told you that I have to find h and k. Remember what h and k represent. They represent the coordinates of the center of the ellipse. If you look back at the sketches that I made on the previous page, the center is always halfway in between the two foci. For that matter, it's also always halfway in between the two vertices. So all I have to do is look at the coordinates of my two foci and then say, where's the midpoint? So here are my two foci. What's halfway in between? I guess that would be 4, 2. That must be the center, which means that h is 4 and k is 2. Now we just have to find a and b. To find a, remember what a represents. It's the distance from the center to one of the left-right vertices. I've got a left vertex right here. So this distance here, that must be a. And what is that distance? Oh, I didn't label this point. Remember, that's the vertex. It's at 1, 2. So this distance right here, a, goes from 1 to 4. That must be 3. So we know everything except for b. How do we find b? b is the distance from the center to one of the up-down vertices. The problem is I don't know where those vertices are. So how do we find b when we don't know these up-down vertices? Well, there is one piece of information that we can extract from this diagram that we haven't used yet. Namely, we know the distance from the center, which is this point right here, to the foci. Right? The distance from this point, 4, 2, that's the center, to this focus at 5, 2, that distance is 1. And that gives you c. Remember that c is the distance from the center to one of the foci. So, how does that help us find b? Because remember that a, b, and c are related by the following equation, or really two equations. We have c is equal to a squared minus b squared, or c is equal to root b squared minus a squared. Remember, there are two formulas. One, when you have a horizontal ellipse, in other words, when a is larger than b, and another when you have a vertical ellipse, in other words, larger than a. We know what a is, distance from the center to one of the vertices, that's 3. We know what c is, distance from the center to one of the foci, that's 1. So we can plug those into one of these equations and find b. However, we have to be careful about making sure we use the right equation. Which one should we use? It depends upon whether you have a horizontal or vertical ellipse. In this case, our foci are to the left and right of the center, which means that we have a horizontal ellipse. Remember that horizontal ellipse, your foci are left and right. Vertical ellipse, your foci are above and below. Because the foci are to the left and the right of the center, we know that we have a horizontal ellipse, which means we should be using this equation, right? So if I plug the known information into this thing, I have c is equal to 1, so 1 is equal to root a squared. A we said was 3, so that's a squared is 9 minus b squared. And then we can solve this equation for b. You should begin by squaring both sides. 1 squared is equal to, and when you square the right-hand side, the root just disappears. Now subtract 9 from both sides. This is, of course, just 1. So 1 take away 9, that's negative 8, is equal to negative b squared, meaning 8 is equal to b squared, so root 8 is equal to b. Well, we now have h and k, right, the coordinates of the center. We have a and we have b, so we have everything we need to write down the equation of this ellipse. All we have to do is plug those values into this general form. So what is our equation? It's x minus h, which we said was 4, quantity squared, over a squared, that's 9, plus y minus k, that k was 2, quantity squared, over b squared, which is 8. And that's going to be equal to 1. And that's the equation of the ellipse. So just to be clear, whenever you're given one of these problems where you're given some random information about, foci are over here, and you got a vertex over here, or whatever, the way to do it is to begin by drawing a picture, right? Plot the points that you're given, label them with their coordinates, and begin extracting information. Like, can you find A? Can you find B? Can you find C? And typically, or very often, you're going to have to use this equation here for C, which relates A, B, and C, to find a missing variable, right? In this case, in this example, we knew A and C, and we had to use this equation to find B. Just be wary, make sure that you use the correct equation. This is the equation for when you have a horizontal ellipse. This is the equation for when it's a vertical ellipse, right? Okay, so that's it.